Hello everyone, this is John Everest and I'm going to give you a short discussion on one of the limitations of using the three-phase daylight calculation method. I think it's quite important and I'd like to make you aware of this. So I'm going to jump straight in. Now, what I've got here is three scenarios. About just for your reference, I'm doing this via Honeybee Plus for Grasshopper. Yeah, so there is a three-phase recipe for doing those daylight calcs. Now, let me just set that back up. What I've done here is I've got four scenarios, right? Just for this to be of value to you, you need to just appreciate what a two-phase calc is and what a three-phase calc is. I'm not going to go into that. I just want this to be a short five-minute discussion. Now, I've done I have a generic building here. It is just simply a building with two windows. The windows are made from the BDSF material, and it's just 6% transmission. The quantity of light is irrelevant. We're going to be discussing the pattern. And what I wanted to show you is when you sort of you're making your window materials and you assign the windows of the same material for your three-phase calc. I just want you to highlight how all windows are treated the same. If you're doing it via the Honeybee Plus route, it is the same to say that what you put in a group here, so both these windows are in the same group for the three-phase calc, not the two-phase, for the three-phase calc. They're in the same group, and what that means is the light distribution, not necessarily the light quantity, that will be adjusted for the size of the window, but the light pattern from the daylight will be identical for both rooms, and I'm going to show you what that means and how it can go wrong. So let me just get back to here. Okay, so firstly I've done the basic two-phase calculation. That is, and what that means is literally just from the sky straight to the calculation points through the windows. And as you'd expect, so the contributions from each window are bespoke, that is to say. And not surprisingly, yes, so we get these patches of light in front of the windows. Now, can I turn preview off on both of those? Yes, I can. Now, here's the two-phase with an obstruction. It's exactly the same calc, except I have see that, an obstructing, I've literally just put a panel in front of that window. The window is still there, but there is a panel blocking light from going into that window. And not surprisingly, the light pattern is now light falling on the surface in front of the window. However, there is nothing, or there is far less compared to the previous calc of light coming in here. Okay, that is obviously as we'd expect. Now I'm going to move to the three-phase calculation. So what that means is the windows are actually turned into light sources. The external light is calculated. The external light is sort of collected onto the outside of the window. The window then becomes a light source and transmits the light inside. And the geometry is exactly the same. The calculation method is different, but the results are the pattern of light is as we'd expect, isn't it? We have two windows and we have bright patches in front. So now watch this. Now this is the three-phase calculation with the same obstruction as before. To labour a point. So this is what we had with this is like, it's straight from the sky through the windows to these points, and we can see the shadow. That is what we'd expect. But look what happens if you do a three-phase with the windows in the same group or using the same material. We still have identical patterns, yeah. So even though this window is totally blocked, we still have light coming through, and the patterns are identical. So this is massively inaccurate, isn't it? Because this is not what would happen. And the reason this is happening is because when you have windows in the same group, or which is the same as saying of the same material, when you feed it through to Arcontrib or Rflux, if you know your Radiance command line, what is happening is because they are of the same material, it's basically taking an average. So can you see there's light coming through on both, but if we compare it to the two phase with uh, oh, sorry. So, but if we compare it to the three phase without an obstruction, hang on, I've got this. The mouse button doesn't work properly. Can you see how it's like? Basically, it's as good as half the light. Yeah. So there's without. This is going to confuse you, isn't it? Right. There it is without the obstruction. Notice the color. So that is to say, it's let's say it's about, let's just say it's 2,500 lux, 2,500 lux there. Now, with the obstruction, so what should be happening is we still have the sort of 2,500 here, and we should have like 300 or something, which is purely bounce light over here. But what is actually happening is three phase with the obstruction, we're getting about 1,000 lux. And so notice it is half the quantity as before, and the reason for that is it is taking the average, it is sampling, it is, because they're the same material, it is collecting the light falling from the sky onto this window, it is collecting the light falling from the sky onto that window, it is taking the average, and it is sort of then on the internal side, the view matrix calc, it is then putting that light inside. This is a very inaccurate calculation because that is not what was happening. Basically, it is taking half of the quantity of this and it has put it over there. So you really need to be careful of when you're grouping your lights together, or assigning them identical, grouping them or assigning them identical materials. It achieves the same, but it does the same thing. It could be fundamentally wrong. So you need to decide on when you're doing your modeling. One is, what are the obstructions? If there is no obstruction, it's absolutely fine, but you need to make that call. So like if you've got an obstruction and it's like over here sometime, it's depending on the scope of what you're trying to do, it might not matter. It depends how accurate you need your calc to be. But this is an exaggerated example, but it just shows how it's labouring the point that you should be aware that this could happen with your calculations. Perhaps if there was a, let's say, I don't know, let's say there was a wall here, that could make a very big difference between this window and that window. The way you would get around it is you would, if you're using command line Radiance, you would obviously assign them unique materials, then feed them through to Rflux. If you're doing it in Honeybee Plus, each of those windows needs to be its own group. Which group? It's like the size of a, trying to work on a screen here, the size of a fag packet. There. So you would need to put a window into its window group, and then you'd need to put another window here, the other window, into its own window group. Then they will be considered individually, and then you would need to combine them over on the over on the other side via your via your hourly, the blind state method. That's how you do it. I hope that's clear and useful, and it's just something to be aware of. It's not saying the three-phase calculation method is inaccurate. That is not the case. It's just saying this is a phenomenon that could happen on your three-phase calcs, and you should be aware of that and make sure your methodology is fit for purpose relative to the environment. Okay. I hope that's helpful to everybody.